Hi everyone, welcome to another MATLAB Crash Course Series lecture. Today we're going to be looking at functions in modular programs. I apologize, it's been a while since I posted a lecture series video. Everything's kind of crazy right now, and I apologize for the audio being a bit off. I don't have my roommate's microphone to borrow, so unfortunately my laptop doesn't have the best audio, but we're going to make do with it, let's have some fun. All right, so the topics we're going to look at today, we're going to look at basic function structure, we're going to look at function input and output, we're going to look at return values versus printing with functions, we're going to look at sub-functions, and we're going to look at modular programs. This lecture video that I have right here is very example heavy, as in I don't really have any exercises for us to do with this. I just have one big example that I'm going to be showing just to kind of represent the key focus of this lecture, which is modular programs and how different functions can work together in order to achieve a goal. So let's get started first with everything else. Everything else here isn't the most important. Knowing how functions work is pretty important, but modular programs is going to be the big focus of today's video. So let's get started. So basic function structure. We talked about this one a little bit when we talked about writing scripts in MATLAB, but not all too much. So just a little review. So as review, functions in MATLAB are specified scripts that allow for immediate input and output of variables. To specify a function, the top of the new script must have something similar to the line below. So this line here, this line is known as the header, and it has a very specific format that you must follow. It has to have the word functions, has to have your outputs here. Outputs, you don't actually put the word outputs. Here you actually put the word function. Here you put your outputs, meaning your output variables. So what variables are expected to be your output of your function? Here you have your function name, meaning just the name of your function, what is it called? And here you have your inputs. What variables are the user expected to put in? That's a key factor when it comes to functions. We're going to look at an example and hopefully it makes more sense, but it's going to contain all of these four different components. It's going to have the function, it'll have the outputs, the function name, and the inputs. The inputs and outputs are optional, meaning you don't actually need these to make a function work. You just need function and the function name, but outputs and inputs for almost every function, you're going to have one. Directly underneath the header, comments can be placed to specify what the function does, and they can be accessed using the help function. I'll give a demonstration on that in a second. After the comments, the body will contain the code that actually completes the task. At the end of the function, the keyword end is placed, much like loops and if-else statements and switch statements and everything we've been working with previously. So the best way to see it is just to give an example. So I have a simple function that we have just called calc triangle area, and all it does is just calculates the area of a triangle given a base and a height. So this is going to be a little bit different than what we've looked at previously, as you can see here. So for example, I can say calc triangle area, give a base and a height. I could give a base of 4 and a height of 8. The answer will be 16. That means that the area calculated is in fact 16. This is a little bit different than what we've done previously because we gave the function specifically an input and an output. We didn't wait for it to ask like, please enter the base, please enter the height. We just, directly give a base and height for the function to use, and it calculates an area. So you can see, as you can see here, we have our function. Here, this is the comment I was talking about that you can access with the help function. So for example, if I type help calc triangle area, it's going to print out that exact line, calculates the area of a triangle and returns the value. So it's kind of nice to have that there. Almost every function should have some documentation. This is the body of our code here that actually completes the specified task. All right. Now let's take a little bit of a look here. So we have our base and our height. That means those are values that the user specifically gives. The user must enter a base. The user must enter a height. In our case here, we said 4 was the base and 8 was the height. Now that we entered those variables, our program, our function here, can directly use those variables for calculations. So we can use base and height. We're saying, okay, assuming that the user gives us a base and a height, we're going to say that the area is going to be 1/2 times that base times that height. And area is our output variable, meaning that's the value that's going to get printed to the screen. And we can see that the script actually knows that we're looking for area because we put that keyword right there. We put the variable name area here, so this function knows to return the variable whose name is area. That's how it all kind of fits together, but we're going to get a little more specific. We're going to look at function input and output, which is kind of what I was explaining a little bit. So a key component of functions as opposed to scripts is that they allow for direct input and output of variables from the function. I talked about this a little bit. Previously, we've used the input function. We've used the fprintf function. We use those functions for the input and output variables, which isn't generally the most common coding practice. Fprintf can be common, but when you're using functions, you don't want to just print out a value. You want to actually give a value back. You don't want to just print it to the screen. You want to say, here is the variable. It is just this number. We don't need any words. We don't have to worry about formatting or anything in this case. With functions, the user can directly enter one or more variables into the code to receive one or more variables as output. You can put your variables for input, you get variables back for output. Note, not all functions necessarily have to have input or output variables. I kind of talked about this at the beginning. Those ones perform almost identically to scripts. So like scripts that we've seen earlier where there's no input and output, a function that has no input or output variables is going to behave basically the same as a script. So let's take a look here what we were talking about just a little bit more. So our input variables, base and height, output variable, area. The function is able to use these in order to complete the common task. As the user, we must enter the 4 and the 8. Now what's really cool about a function like this where there's an output variable is that we can actually then assign a variable to that answer. So we can say in here area, or let's say triangle area equals calc triangle area for 8. The variable triangle area now equals 16, and I can use triangle area in any of my other calculations if I want to. I can say triangle area plus 4, that would be 20. So that variable, as you can see in our workspace, is stored right here under triangle area. A function allows us to get that value. If we just had a script and we just printed out fprintf, we wouldn't be able to use that variable anywhere. And that kind of leads into my next point that I have, which is going to be return values versus printing. So there are different ways of returning values to a user depending on the main purpose of the function. Return values is what I just talked about. A return value allows for a value to, well, be returned to the user. A variable is simply returned to the user without any printing, formatting, etc. None of that, similar to how one would receive the output of exp5. So like, your normal functions that you have here. So if I say like exp of 5, note that I get just answer equals something. That's the exact same way return value works. If I say calc triangle area for 8, I get answer equals 16. It works the exact same way. When executed from the command line, the user would see answer equals some value. The user could then use this value for other calculations, and I showed that with the triangle example. Printing. A variable is not directly returned, but is printed on the command window using fprintf. So this is just printing a value. This is just showing the user what your value is, but not giving it to them so that they can use it for any calculations. That's sometimes if a user kind of front-end material here, if a user just wants to see the value, but the user shouldn't be given access to the value, you just want to print it. There can be formatting allowed to make it look nicer, which is a plus, but the user cannot use this value for any calculations. That's a key fact here. We're just looking at this value. We're not actually using it. And I have another example that kind of shows the differences between these two. It's going to be print triangle area. In this case, there's no output variable here. There's none of the output. In the previous one that we had, which is right here, we had area equals calc triangle area. Here we just have function print triangle area. The user still has to give an input and input for base and height, but in this case, we print the area to the user. We say area of triangle and we print the area. So let's do that example. So if I say print triangle area for 8, area of triangle 16, but now notice, well, actually first, so area of the triangle 16, but note that 16 isn't stored anywhere in my workspace. We don't have that anywhere because it's not an output variable. Area is not an output variable. If I even try saying like previously, if I say triangle area equals print triangle area for 8, too many output arguments because it expected no output arguments. So that's a key fact here. This example, we just printed. In this example, it actually is returned to the user for calculations. It's kind of a key fact here. In a lot of functions that you have, you're going to want an output variable, and we're going to show how that kind of works in our modular program at the end. Last kind of small topic I want to look at, subfunctions. Functions we've discussed so far are known as primary functions, which are simply functions that complete a task. Those triangle area functions, those are both primary functions. Other functions, although, can be placed in the same file as the primary function to allow for tasks to be split between multiple functions. A function that's placed beneath the primary function is known as a subfunction. So you can allow for multiple functions within the same script, the same .m file. These subfunctions can only be used within the primary function. They can't be directly used on the command window. So these subfunctions that we have only exist in the term of that script, in that file. We can't access those functions just on the command window or within another function. We have to only use them within our primary function. Subfunctions are useful for splitting up tasks, but not necessarily the most efficient means of doing so. So I have one example to look at. It's a very simple example of subfunctions. Not really a topic you're going to see too much in MATLAB, but you can utilize it if wanted to. It's good for refactoring, meaning breaking up your code into different pieces so that you don't just have one giant function that does all these different things. You break it up into multiple functions. But this might not necessarily be the best way of doing so. Print sphere volume I have here. Let me get rid of these other ones here. So print sphere volume, this is our primary function that we see. It's the first function here. The first function is the primary function. It prints the volume of a sphere given the specified input radius. So you can see here, what we first do, the first task we do is call this calc volume function. We don't have a calc volume function except in the script we already have. Calc volume is our subfunction that we have. And what this function does is it takes a radius and gives a volume. So it's a subfunction to return the volume of a sphere. The only thing it does is calculate the volume by doing 4/3 pi r cubed, where r is the radius. It takes the radius, cubes it, 4/3 pi, and it gives you your volume. This volume is your output variable. So what it does is it calculates the volume of the sphere and returns the volume back to whoever called it. In this case, it's the primary function that called it. The primary function takes the radius it was given, gives it to the calc volume function. The calc volume function goes, calculates the volume, calculates what the variable for volume is, and returns that variable back to the primary function. So volume, this volume here is going to equal whatever was calculated in this function here. That's the purpose of a subfunction. It's in order to break up your code. Instead, we could have had that line here, but in this case, we broke it up, and that's good for other people that are looking at your code. Instead of having a giant long line of multiple, in this case, it wouldn't be much longer, but in some instances, you might have functions that do all these different things, and you really only want a function to complete one specific task. Everything else should be broken up into other functions. In this case, that's what happens. In this example here, all this function, this primary function is doing is printing the volume. To do the actual mathematical work, to compute the volume, that's the job of the subfunction. The subfunction calculates the volume, the primary function goes back and uses it and prints it out. So you can see here if I actually print sphere volume, let's say we had a radius of 5. So what ends up happening is it took 5, calc volume then, or print sphere volume then called calc volume with that number 5. So 5 is the input of the function calc volume. We have an input of 5, the volume is calculated by 4/3 pi r cubed. Volume is then calculated to be 523.6. That value is then returned back to volume, and the volume and radius are printed in these fprintfs. So that's what a subfunction is used for, but it's not necessarily the most efficient way. The next topic that we have is a much more efficient way of actually using multiple different functions to complete a task. So the final and biggest thing I want to talk about in this lecture is modular programs. So modular program is a program in which different capabilities or different actions are broken up into different modules, and each module is represented as a function. Modular programs are extremely important as they are used to develop prime code in which tasks can be directly split up into these modules. Essentially, each task in an overall program can be developed and analyzed individually, which is the optimum design for coding overall. The rest of this lecture consists of analyzing modular programs and how those various pieces fit together. So this is all just a bunch of words here, but essentially what it's saying is that a modular program consists of multiple functions broken up in their own .m files. These .m files are functions, and these functions work together to complete a task. All these files must be placed in the same folder on your computer, the same directory, and then they can all be used together to complete a goal. So let's see what I'm talking about. So there were a lot of functions I didn't use here, so let's ignore the calc triangle function, the print sphere volume, and the print triangle area. All the other functions I have here are used for a modular program I've developed called Yagmore-Banks. Yagmore is my last name. But so Yagmore-Banks is essentially a little application I made to make your own little online bank here in MATLAB. So I'm going to actually run it for you. Yagmore-Banks. So you can see there are a lot of different capabilities we have. So it says, welcome to Yagmore Banks. This application is meant to allow for the ease of transactions made through Yagmore Banks. And then there are seven different options. So you have your own account through Yagmore Banks from what I've created here. You have 7 different options we can do. You can make a deposit, make a withdrawal, take out a new loan, pay off an existing loan, examine current status of your account, examine the progress that your account has made, or exit. Okay, so I've started off right here with nothing, okay, $0. So if I examine my current status, it'll say current balance 0, and I've actually made it so that it automatically doesn't keep printing off this each time, it actually exits and starts over again. So it'll say current balance is $0. So then I can use the make a deposit feature. I'll type 1. Yagmore Banks ensures peace of mind with all of its transactions. Please enter the amount you would like to deposit. So then I can enter 500 per se. Total amount saved, 500. It exits, so if I examine my current status, I have $500. Here's the really cool thing I did about this program though. If I exit, thank you for choosing Yagmore Banks, see you soon. If I rerun it again, so let's say I go ahead and rerun it, so Yagmore Banks. If I look at my current status again, it saves as $500. It doesn't forget everything you did. I have this user.dat file, which is a data file that every single time this program runs, it saves the values in here. So let's try another thing. Let's make a withdrawal. Please enter the amount you would like to withdraw. So let's say I want to withdraw $25. Now there's $475 in. So with my current status, I have $475. Let's take out a loan. So I can take out a loan through bank. It must be paid back with 5% interest. So let's say I want to take a loan of $1,000. So I have to pay $1,050 back. If I look at my current status, which is 5, 475 and 1050, let's look at one more time. 1050 is the amount that I need to pay back through loans. Now I did something where if I try to take out a new loan, it says your current loan must be paid off before you can make a new loan. Sorry, it's kind of going a little fast, but must be paid off before you can make a new loan through Yagmore Banks. So I can pay off an existing loan. I have to pay off 1050. First, maybe I can pay off 500. So I still have to pay back 550. If I look at my current status, pay back 550 still. Let's say I want to pay back the rest of it, so I'll pay back 550. Now my loan has been paid in full. So this is a little program, we can do all that. If I look at my current status now, I can take out a new loan if I wanted to now. Take out a new loan, let's say enter 10. So now 1050 need pay back. I'll pay that off real quick. 1050. Examine progress of your account. So this one actually shows you a plot of all the different deposits you've made. So let's make another deposit. Let's say $400. And let's make one more deposit, $1,000. So now if I type 6, it prints out a plot of the deposits you've made. So start with 0, and then I went up to about 500 or however much that was. I took out some. I went up again to my current value here. So this plot shows you how much money's in your account over time. So, and then exit, just exit out. If you enter something that's not there, so like 56, it just says invalid input and starts again. And then I can exit if I want to. So, as you can imagine, this program takes a few lines of code. And what one person could do is type one giant function that has all of these different capabilities in it. Just one massive function that does all of this stuff. But that would not be efficient, because when you're looking at your program and let's say you're trying to figure out what's wrong with your program, if you're debugging it, the next video that we have is going to be over debugging, it gets really messy. It gets bad. You have this giant function that does all these different things, and the most efficient thing you can do in MATLAB is split it up into different functions that each accomplish something else, something different. So we're going to actually look at the code for this now. So Yagmore Banks. So this, have a comment here. This application, let's expand this a little bit. What are the problems here? That's not important. So the Yagmore Banks application allows for any user to hold their own bank account to allow for deposits, withdrawals, and loans. All users can make as many deposits. All loans must be, that part's not actually applicable anymore, so I'm going to delete that. So here I have my function. I say, welcome Yagmore Banks. This application is meant for ease of transactions, blah, blah, blah. I have all that stuff here. Here's where I load my data. I calculate what all the stuff should be, the total, the loan, the history, and then exit is currently defined as false. So then I do something. This is the choice. This is select option function. I say choice equals select option, and there's no inputs. So what I do here is in my main function that starts, that function you see at the beginning, if I were to like run this right here, I were to say Yagmore Banks. So this first part here is the start of this function that we have here. But then this here is printed all through the select option function. I'm just going to exit. So let's see, select option function. So that's the next function that this program calls. So let's take a look at the select option function. Select option allows the user to select which option they would like to proceed with. So what this function does is it prints out all the different options. So I could have printed out all those different options over in this one, the main driver function, Yagmore Banks, but that would be including stuff that's not pertinent to the main function. I want to split things up as much as possible. So I'm able to split them off by having my own separate function, select option. All it does, it prints out all the options that they have, and then choice equals input, please select an option from above. So then it prompts the user to select an option. So it goes ahead, choice equals input, select an option from above, and that value choice is the output for this function. Meaning that whatever the user enters, this variable choice, whatever they put in here, will get sent back to Yagmore Banks, the function, and established as this variable choice. So then I have a while loop that goes, while not exit. As I previously said, exit equals false. So essentially, once the variable exit turns true, then the program will stop. Other than that, this will keep running over and over and over again, meaning it'll keep asking the user which option they would like. And that's what we see in our program. It keeps asking what option like over and over again until you enter 7. At 7, exit equals true, and then when exit is true, this while loop is false, and then it continues as normal. It says thank you, and it saves all the data so that next time you go and you upload this, all that data is still there, it's not gone. So now we have to look at the meat of this. All of this is the key of modular programming. So in our example, this menu-driven program I have, where it's like a menu, you say, okay, what do you want? 1, 2, 3, 4, 5, 6, or 7. Here, we have a switch case statement that says, which one did you pick? Did you pick 1, 2, 3, 4, 5, 6, 7? If we picked 1, that was the deposit one. That allows you to make a deposit. Here, I have a make deposit function. It takes in the total value, or the value that's currently in your account, and the history. The history, which might be is not too obvious, but the history is a vector that contains all the values that have been in your bank account previously. So all your previous total values are in history. That's what I used to make that plot at one point, the plot history. All those values are stored in that vector. So that's how your history is kept and how this program knows all the different deposits you've made. But so what it does is it takes your total, takes your history, and it gives you a new total and a new history back. These are the same variable name, but in this case, total and history are one value, but when they come back from the function, they're updated to a different value. So now let's look at the make deposit function. So what make deposit function does is it takes a total and a history and gives a new total and a new history back. So let's see, this function serves as a method to ask the user how much they would like to deposit into their account. So it prints out something and then it asks for an input. Please enter the amount you would like to deposit. It gives it as an input. The deposit function then takes in a value. What I do is I round it to 2 because we're dealing with money here and it should round to the nearest 2 decimal points. And then it updates new total equals whatever your previous total was, the previous total being this input. It takes that value and adds the deposit, the value that the user entered when it asked for a value they'd like to deposit. So the new total equals total plus deposit, and then new history equals history new total. Essentially, this is just a way of adding one beyond your current vector. We have a vector history right now. We're just adding a value at the end. New total is our new value that's added at the end of the vector. So new history is updated with all those values. And then it prints out the total amount saved. Hopefully that all makes sense. So what happens then is we're given a new total and new history value. When it returns back to Yagmore Banks, total is updated to the new total, history is updated to the new history. Because when you enter that money, that deposit, it then takes that total, updates it, the history is updated, and everything's all hunky-dory now. And then it starts over again. If you print your current status, you'll see that your deposit's new. Let's look at this option now, make withdrawal. This almost does the exact same thing, it's just a little bit different. And I have a few other options here. So it ensures peace of mind, blah, blah, blah. Please enter the amount you'd like to withdraw. I round the withdrawal option, or that number again, I round it to the nearest 2 decimal points. But then what I do is I update total savings, check to see if they withdraw more than what is in their account. So if the amount they withdraw is more than what's currently in their account, which is the total value, it says your requested withdrawal amount is more than the amount currently in your bank account. And then your new total, new history stay the same and your program exits. But if withdrawal is less than your total, meaning they actually withdraw a number that they have, the new total equals total minus the withdrawal because we're taking money from the account. New history equals history, new total. We're adding new total to the end of our vector. And then it just prints out the total amount you have saved. Once again, this is another function. We have our input total and input history just like for the make deposit account. And then what's returned is a new total value and a new history value. Then when you go back to Yagmore Banks, you'll see that total and history are updated. They're up to date. It's the new value that you stored. So this is how the deposit and withdrawal works, how it uses a separate function to go and complete a task. So I don't have to put that stuff in here. Because if I put all that stuff in here, it's gonna get confusing. There's gonna be so many different things, but with the make deposit function, I can then work just on this deposit function by myself, knowing that all the information related to make deposit is in here, knowing that all the information related to make withdrawal is in here. So let's see. Let's look at the loan options now. So take loan. So the only thing that you enter in here is the value loan. And then what's outputted is the value loan. Loan at the beginning is just the value 0. Loan from the start is just 0. But when it goes to this function, take loan, let's see, take loan. So we got a little bit going on here. Let's see. So takes a loan from the bank and updates the value that must be paid back by the user. Check to see if the total loan value is 0. So if the current loan value is not 0, the only way they can take a loan is if their value is currently 0. If it's not 0, they have to pay off that loan first. So what this function does is it takes the current loan we have as input. So that's the value that is entered, that loan value. That value right here. That's entered as current loan. And what we do is we check to see if it's 0. If it does not equal 0, we'll say your current loan must be paid off before you can make a new loan through Yagmore Banks. You still have, and it tells you the amount you still have to pay back. That value is going to be stored in current loan. We say loan is equal to current loan, meaning we don't change the loan value, meaning that nothing happened. But if current loan does not equal 0, then we can take out a loan. So it says, F, please note that all loans are made, 5% interest, blah, blah, blah. Please enter the amount you'd like to be loaned. If loan is less than 0, so they enter the loan value here. But if loan is less than 0, that's an invalid input. You can't loan a negative money. So we're just going to say invalid input. But then we say else, loan equals 1.05 times loan. Because remember, they have to pay back with 5% interest. Meaning that their loan is going to be 1.05 times whatever number they entered as their loan. Then it says the amount to be paid back. We have the loan. And that value loan gets sent back to the driver function, the main function, Yagmore Banks, and stored now as the new loan value. Contrastingly, the pay loan function is used to basically do the opposite. We have our pay loan function. We have a few in here as well. So we check to see if it currently is 0. So they're trying to pay back their loan. But if current loan, the input value from this function, loan, if that value equals 0, they have nothing to pay back. So it says you have no loans that need to be paid back at this time. Loan still equals 0. And it goes back, and this value is still 0 then. But if the original loan value is not 0, else, it says the current amount to be paid off is, it tells you how much to be paid off, and then it says enter an amount to pay. The user enters an amount to pay, amount paid, we round it. If amount paid is less than 0, or if amount paid is greater than the current loan, basically if they entered a negative value, or if they entered more than what they have to pay back, so let's say they have to pay back $500 and they enter $1,000, that's more than they have to pay, we're just going to say invalid input. Then we're going to say that's our current loan. So loan equals current loan minus the amount paid. If loan equals 0, which is what happens if they pay back their entire loan. So if they pay back the entire loan, we're going to say your loan has been paid in full. If they haven't, then we're going to display how much they still have left to pay. And that value of loan is the output for this function, and that is the value that's updated here. So that's how these 4 different functions work. These 4 functions all work together in order to complete this task that we have, in order to make a deposit, make a withdrawal, take a loan, or pay back a loan that we currently have. Instead of having all the code written in this switch case statement that we have, we're able to split it up into these different files. Split it up so that we're working with less. We don't have to have all this giant function in here. We're working with various parts and pieces, and then we can, in this main function, YAG more banks, we can have all those pieces fit together. Let's look at the final things that we have here. So current status, we have total and loan. So current status, all this one did was print off the current status of your bank account. So the only input values it took were your total and your loan. The total being the total amount in your bank account, loan being how much do you have to pay off right now. So if loan is greater than 0, well, let's see, actually first. So all it does is it prints current balance is, and it prints out your total. That's the input value. Notice that there's no output value here. There's no output value because we're not outputting anything to the user. We're just printing something. We're not outputting anything to this function. So current status, it prints off your total. If the loan is greater than 0, meaning they do have a loan, it says amount to be paid back through loans, and it gives you the loan value. So in this case, this is an example of a printing function, a function that just prints out to the user, but it isn't used for any calculations because we already have those values. Total and loan aren't changing at all. All we're doing is printing what they are to the user. The final one we have here is plot history. And this is the first time we're actually going to use our history value, this vector, to do something besides just updating. So in that example, once again, there's no output function because we're just plotting something. We're not changing any values or doing anything. We're not expecting any output. We're just plotting, plot. So plot history. This plot shows how the amount in the user's account has changed from each deposit. So we create our x-axis, which is just 1 through however many values there are. That's going to be deposits made. Then we're going to go ahead and plot our data. So as you can see here, I just mess around with the figure a little bit. I say the name of the figure's account name. I turn off the number title, which you don't have to worry about that right now. That's just some stuff to make it look a little bit nicer. I plot the deposits made to the history. That's how we see that plot emerge. That plot that we had here, that's how we see it emerge. Then I customize my plot by changing the X label, Y label, and the title, and I fprint F. So that was almost the final of these. Let's look at exit real quick. So all case 7 does is it switches exit to true. If you enter something that's not 1, 2, 3, 4, 5, 6, or 7, it just says invalid input. And then if not exit, we ask for their choice again. Basically meaning once this while loop is done, as long as they didn't pick 7, we ask them for their choice again. And then it goes back to the select option function. Remember, that function asks the user what option they wanted to pick. That choice equals input select option. We go back, we select the option, and we go back here. And then if we selected 7, meaning we set exit to true, we go ahead and say while not exit, and then we continue with the rest of this. I think the most important takeaway you can take from this example I have here is understanding the different input and output features of each of these functions. Look how all of them work. In these 2 functions we have here, they have 2 inputs and 2 outputs. In these 2 functions we have here, we have 1 input and 1 output, loan and loan. In these 2 examples, we have inputs but no output. We have 2 inputs here but no output. We have 1 input here but no output. In the select option, we have no inputs but we have 1 output. This is one of the really cool features of MATLAB. Other programming languages don't really have these cool capabilities. Like Java, C for example, they allow for multiple inputs, but a lot of those only allow for 1 output. You have to do weird other things in order to get multiple different outputs. But in MATLAB, you can have multiple different outputs if you want to. Or you can have no inputs and just 1 output. Or you could have 1 input, no output. Like here, you can have a 1-to-1 ratio. It's completely up to you. And that's what makes MATLAB and coding really cool, is it really allows for you to be creative with how you develop your solutions and how you can use functions in a way that gets the job done. That, in the end, that's really the most important thing, getting the job done. This is MATLAB here we're talking about. That's not other coding languages. We just want to get what we want accomplished. And with these functions, we're able to break it up to make it easier for ourselves so that you don't have a really long function. Because all of these different, this whole thing, this here is only almost 60 lines of code. But if we include all these other things, this is about 20 lines of code, another 10 lines of code, almost 20, upwards of 20. You're going to end up with a lot of lines of code in the end. And you want to break it up. You don't want a function with so many lines of code, because then that gets really ridiculous and just a lot to deal with at that point. So breaking it up, creating a modular program like this allows for effective work. Now in this example here, I have like a menu-driven function. Functions don't need to work like this. It doesn't need to be like a menu. It doesn't have to be like, all right, select 1 to do this, select 2 to do this. It can just be like functions are working normally throughout your program. Kind of like this example here. We didn't have to select any option to run the function. It just went ahead and completed this function, select option. So all these modular programs are able to work together to efficiently run. All these functions are able to create the modular program here, so that you can go ahead. This, as you can see here, the select option function was an action right here. This right now, what I'm currently in that select option function. And when I select 1, I'm returning 1 right back to this function here. I return 1 here. So choice equals 1. I go ahead, switch choice, case 1. I enter my total and history into the make deposit function. The make deposit function then activates. And then look at this line right here. These 2 lines are exactly what we see right here. So now we're in the make deposit function currently. The next value I enter is going to be that deposit variable. I can say 200. Right when I enter this, it's going to round it. It's going to update my total, update my history, and print what my new total is. My new total is 2075. And then it takes me back to here. In case anyone's curious, I'm able to like delete all my existing code using the CLC function that I have here. CLC just deletes all the stuff that's currently in your command window, and the pause function is used in order to wait a little bit before delete, so the user can look at what happened and then remove their stuff. So if I select like 4 here, you have no loans need to be paid off. It waits like 1.5 seconds and then it goes back to the beginning. So, and then you can click 7 to exit. So this is how a modular program works in this case. I know this is a little confusing. This is one of the more abstract topics of MATLAB. This isn't dealing with just computation or matrices or an easy input-output. This is a big part of design, but design is really important with your code. If you are working in a laboratory and you're doing research and you want to create a function that's utilizing machine learning or utilizing anything, you need to make it look nice, because chances are someone might be using those functions or that code later at some point. They need to understand how it works. In order to do that, your design needs to be good. And so that is all we have for today with Modular Program. Thank you so much for watching.